Hi everybody, my name is Ria and I am going to go over my results for Lab 2. So to start off with, this lab shows us the effects of Newton's second law, which is the final velocity is equal to the initial velocity plus the net force multiplied by the change in time. In previous labs, we've seen the net force is typically just affected by something as simple as a push, and in this case, the net force will be the force of gravity pointing in the downward direction, which can be seen in the free body diagram to the right over here, plus the force of drag, which is in the positive y direction. So there's two more components in calculating the net force. So the objective of this lab is to observe the difference in the same object falling using a computational model accounting for just gravity, a model accounting for both gravity and drag, and then our observation. So to start out with, for my observation, I dropped a soda can that was empty from a height, and this is the data that I got from trackers. As you can see right here, this is my change in position. And then that was also modeled using GlowScript code. So this is my change in position over time graph, and as you can see, it's exponential, pointed downwards. As for some analysis, I then placed this next to the observed data next to the predicted data, which is what I had gotten from my GlowScript code is. And as you can see, as time goes on, the disparity between the observed and the predicted data grows. And that's because the observed data is accounting for drag and the predicted data is not. So to account for drag, I updated my GlowScript code and I ended up finding the magnitude of the drag force as 0.018. And that was just through trial and error. And then I updated my loop here to account for the weight being the mass of the ball, negative mass of the ball multiplied by gravity, which is actually the gravity is the reason for the negative force, multiplied by j hat, which is just the vector 0, 1, 0, and then actually ignore the speed part, and then the drag force being the constant multiplied by the velocity of the ball. So that was also auto updating in the loop. And then the net force was the weight plus the drag force, and then the updated ball velocity took that net force into account instead of just the weight being the net force factor. So in conclusion, one of the possible errors that I could have had was the center of mass was blurry at some points, and that was very roughly estimated. But I think the biggest learning from this lab overall is that the observation is always going to be a little bit different from what is actually predicted using a computer model, but we were able to get kind of pretty close, by taking into account the drag force and the force of gravity. Thank you.